Hey guys, it's Russ again, and I'm here with another helpful web demo. So this will help you if you are kind of stuck with Lab 2 and are trying to figure out, how to use logic gates to implement things. So I'm going to do a small example. So you'll see that what I have here is essentially what you need to complete for Lab 1, right? So I have the 4-bit adder here, and I have my 8 inputs and my LED outputs over here, and it kind of works the way you would expect. So if I add 1 and 1, I get 2, right? So that's all well and good. So you're going to use this board, use this completed Lab 1 as a starting point for Lab 2. And what we're going to do is we're going to do something a little bit different from what you have to do for Lab 2. We're going to do a 1-bit output that detects if the sum of the two numbers you're adding is 1. So it's going to be called detect 1, and its output will be 1 if and only if the sum of the two numbers you're adding equals 1. All right. So the way I think about this is I can think about this as you could think about this in terms of truth tables, or you can write down the corresponding Boolean expression that corresponds to this, and that would be this S3 bar and S2 bar and S1 bar and S0. So that means that your sum bits 3, 2, 1 are all 0, and sum bit 0 is 1. Right? So that corresponds to 1. Right? And then I could think about if I had available to me an AND gate and some bubbles, I could basically implement it this way, right? Okay, that's great. But you'll note that you don't have a 4-input AND gate in your kit. So how can you do it? Well, you can think about it this way. I do have a bunch of 2-input AND gates, and I have some inverters. So I can rewrite my expression this way. So this is now, I've basically factored the terms S3 bar, S2 bar, and the term S1 bar, S0, right? So I could implement what's inside each of these parentheses with some inverters and 2-input AND, and I can take the whole thing and I can basically implement that with another 2-input AND. So my resultant circuit would look something like this. Right? So I'm going to invert S3 and S2, feed those through an AND gate, invert S1, feed that through an AND gate, and S3 bar, S2 bar together, and S1 bar and S0 together, and I'll take those two results and I'll AND those together. Right, so I'll use 3 total AND gates and 3 inverters. And you can easily do that with 2 TTL chips. So the 2 TTL chips that you'll want are the 08 and the 04, right, and these should be in your kit. And you'll see in the data sheets that I have on Canvas that you have pinouts, schematics for the gates. And the way you can think about the gates basically is inside of these IC packages, you're going to have a bunch of these various gates, and their inputs and outputs will be the corresponding pins. So here's a sketch, simplified sketch of these 2 chips of the 04. So the 04 is basically a bunch of inverters, so I'm just going to use 3 inverters, and as you can see, the first inverter uses pin 1 for its input, pin 2 for output. The next inverter uses pin 3 for input, pin 4 for output, and the third one I'm going to use is going to have pin 5 as input, pin 6 as output. I have pins 7 and 14 as ground and VDD, and you can see I have a little notch here, right? So to get the right orientation, right, find the notch in the chip. So if you hold the chip up, right, you'd see a little notch on one side, right? That corresponds to the notch in this diagram. All right, so I could go ahead and I could place that on the board, wire it up, power it up, and I could do the same thing for this other chip, the 08. So the 08, again, pin 14 is VD, pin 7 is ground, and then I'm going to use 3 AND gates, and they're going to use pins 1. The first one uses pin 1 as the input, pin 2 as a second input, pin 3 as an output, right? And then correspondingly, as you can see, right, these other AND gates use other pins for their inputs and outputs as well, right? This is all on the TTL data sheets, all right, that are PDF files on Canvas. So check those out, very useful. All right, so through the magic of TV, I'm just going to go ahead and wire this up and see what we get. All right, and we're back, and through the magic of TV, we're all wired up. So I have my inverters here, my AND gates down here. I tried to use color code, and I tried to cut the wires to like a somewhat appropriate length so that I don't have this big spaghetti of wires. I recommend that you do that as well. Try to color code and try to keep the wires nice and shorter than they need to be, or as short as they need to be. Alright, so let's see if it works. So I've wired this up out here to be my output, and if I try to add, so it's all zeros here, so 1 plus 0 is 1, and my detect 1 sign is on. Alright, so 1 plus 1 is 2, and it goes off. Alright, so let's try negative numbers. Alright, so alright, that's negative 1. Negative 1 plus 0 is negative 1. Alright, so let's try negative 1 plus 1 is 0, and we're back off. Okay. So let's try negative 1 plus 2. That's 1, and my detect 1 is back on. Okay, so good luck, and I hope you learned something.